chapter 4. Okay, and then once you have your 4.1 notes ready to go, just type in R for ready so I know that we're ready to move forward. And so you've been seeing themes. Chapter 1 was an introduction. We learned about the 6 trig functions. We learned our unit circle. That's foundational. Chapter 2, we learned the 6 graphs that correspond to our 6 trig functions. Chapter 3, we learned our group of, or our list of 10 groups of identities, trig identities. And then in chapter 4, we're going to learn to solve trig equations. So solving trig equations are going to combine our algebra and trig skills. So we're moving forward to the latter half of the material, which involves solving trig equations. Great. So I see Miguel, Genesis, Esmeralda are ready to go. Let's give other students a couple more minutes. Okay. Great. I have some message in my DM. So looks like we're ready to move forward.
Recording in progress.
This recording covers section 4.1. So 4.1 is on the inverse trigonometric function. We need to learn the inverse functions before we learn how to solve trig equations. We were already introduced to the inverse trig function back in section 1.5. And we said in 1.5, we're going to revisit and go in more detail in chapter 4. So here we are in chapter 4. Okay. What you're going to observe with all 6 trig functions is they're not one-to-one functions. Meaning that the trig functions pass the vertical line test, but they don't pass the horizontal line test. Therefore, when you take the inverse of the trig function, it's no longer a function unless we restrict the domain of the trig function and the range of the inverse trig function. Okay, so let me repeat that. In order to define the inverse trig function, we have to have a restricted range. The reason is because our trig functions themselves are not one-to-one. So when we inverse them, we have to restrict the range for the inverse function to define it as a function. Okay. At the end of this section, I'm going to summarize the restrictions, but I'll highlight them for us here. For inverse sine, the restricted range goes between negative pi over 2 and pi over 2. Okay, so let me give us some reminders here. In algebra, we learned that exponential and logarithmic functions are inverses. Therefore, the inputs and outputs switch. Here we're going to see the trig function and inverse trig function are inverses. Therefore, the inputs and outputs switch. So sine of theta, that's a ratio. We can write it as y over r or opposite over hypotenuse. For inverse sine, inputs and outputs switch. So that ratio goes inside and the angle goes outside. Okay. Ratio comes inside, angle goes outside. But make note that when you do the switch, because sine isn't a one-to-one function, when you do the switch, there's now a restriction for the angle, that the angle must be between negative pi over 2 and pi over 2. So since sine is not a one-to-one function, when we do the switch, there are infinitely many angles to satisfy this equation. but we have to restrict it to make it a function, because for functions, every input has exactly one output. We restrict the output to be between negative pi over 2 and pi over 2. Okay. If we don't have the restriction, we have a problem, because, for example, sine of theta is 1/2. Sine is going to be 1/2 at different angle measures. So the vertical leg is 1/2. That exists at 30 degrees, but it's also true at 150 degrees. Also true at all the coterminal angles. So if we don't restrict our angle, theta, we're going to have infinitely many answers. In the restriction, though, there's only one answer. Okay. A reminder here for inverse sine, we use the notation with that -1 there, or we use arc sine. Those are two different ways we can denote inverse sine. Be very careful not to mix up. So inverse sine is not the same as the reciprocal of sine. So that -1 is not an exponent. It's the inverse notation. It just happens to be in the same spot as the exponent. But that -1 does not represent reciprocal. Instead, it represents inverse. Okay, so for inverse sine, in order to define it as a function, we restrict the output to be between negative pi over 2 and pi over 2. Therefore, for every input, there's exactly one output, and we've defined inverse sine as a function. Okay, for inverse cosine, inverse cosine is going to be restricted to be between 0 and pi. Okay, so we have cosine of theta is equal to a ratio. That could be x over r or adjacent over hypotenuse. The inverse trig function, the inputs and outputs switch. So theta comes outside and the ratio goes inside. Inputs and outputs switch. But again, in order to define it as a function, in order to define inverse cosine as a function, we need to restrict theta. Before we restrict theta, there's going to be infinitely many thetas that satisfy this equation, which would mean inverse cosine is not a function. But to make it a function, we restrict it. Theta has to be between 0 and pi. Then inverse cosine becomes a function. So once we've established the restriction, then the inverse sine, inverse cosine are now functions. Okay. So next example, we'll put a single star here for us to review. Find the exact value. When you see the term exact value, that means express your answer in radians. Okay, I gave us this note in chapter 1, but I'll remind us. When you're asked to find the inverse trig function, you're going to set that equal to theta, remember, because the trig function is equal to a ratio. When you switch the inputs and outputs, the inverse trig function is an angle measure. So we can use theta to represent the angle measure. Okay. Okay, let's do these first two examples together, and then the last two pages, you'll have a chance to try some of these problems on your own. But let's get a feel for how to find inverse trig functions. Okay, so if we want to find the exact value of a trig function, we use our unit circle knowledge. Given the angle, we can find the coordinates. For inverse trig functions, we go in reverse. We're given ratio of coordinates, and we have to go in reverse to find the angle. So that's why we've stated that students do need to know the unit circle thoroughly inside and out. So given input, you can find output. Given output, you can find input. Okay, so inverse cosine of -1/2 is theta. Let's do the switch. In goes out, out goes in. And we have to find a theta value that's in the restriction. For inverse cosine, theta is restricted to be between 0 and pi. Okay, so to help us find a value in the restriction, we'll just draw here the restriction 0 to pi. Cosine is the x coordinate. So the x coordinate is -1/2 right here. Okay. X coordinate is -1/2 right there. And this angle is 120 degrees, but in radians, this is 2 pi over 3. This is 2 pi over 3 in radians. So that means that in the restriction, the angle that satisfies this equation is going to be 2 pi over 3. So what we did there is we did the switch, drew the restriction, found the angle in the restriction. Because cosine is the x coordinate on the unit circle, x coordinate is -1/2 at 2 pi over 3. It's also -1/2 at 4 pi over 3, but 4 pi over 3 is not in the restriction. There's only one answer in the restriction. Okay, try again. Inverse sine of -√2/2 is equal to theta. Therefore, sine of theta is equal to √2/2. So we do the switch, but we do need to remember that for inverse sine, the theta values are between -pi over 2 and +pi over 2. Okay, so we want to find the theta that satisfies the equation, but also lives in the restriction. Sorry, let me try to draw it as accurately as possible here. So -√2/2, that's about -0.7. It's about here. It's the twin group. So the reference angle is 45 degrees. But we need to be between -pi over 2 and pi over 2. So this angle, we can say it's 7 pi over 4. But 7 pi over 4 is not in the restriction. So let's find the coterminal angle in the restriction. If we travel clockwise, this would be -pi over 4. So you have to find the radian measure in the restriction between -pi over 2 and pi over 2. So that would be -pi over 4. Actually, I shouldn't box the theta. Let's just box the final answer here. Okay. So let's call on students here. We'll go to Genesis and Justin. Okay, so Genesis, for arc sine -1 equals theta, we have sine of theta equals -1. Our theta needs to be between which two values? So what is the restriction for inverse sine?
Um, I don't know.
Okay, so we want to put this on our reference guide too. We'll go up here. For inverse sine, the angle will be between negative pi over 2 and pi over 2. For inverse cosine, our angle will be between 0 and pi. We want to learn those restrictions so we know when we do the switch what our angle is restricted to. Okay. So for inverse sine, the theta is going to be between negative pi over 2 and pi over 2. Okay, so it may be helpful to draw a sketch here. So Justin, at what radian measure is sine of theta equal to negative 1?
3 pi over 2.
That's right down here. Okay, let me actually help us by color coding.
Well, technically, right, would that be, would you want us to put negative pi over 2?
Yes, yeah. So
Okay.
it's at 3 pi over 2, but the answer for the inverse trig function that's in the restriction is negative pi over 2. That's correct. So 3 pi over 2 would satisfy the equation, but 3 pi over 2 would not be the correct answer for the inverse sine. It would be marked wrong for inverse sine, since inverse sine must be in the restriction. Okay. 3 pi over 2 is coterminal, but the answer in the restriction is negative pi over 2. Good catch. So let's take a look at what we did here. To find the exact value of the inverse trig function, we did the switch, and we made note that the inverse trig function has restrictions. For inverse cosine, answer is between 0 and pi. For inverse sine, your answer is between negative pi over 2 and pi over 2. Then we drew our circle to find the angle that satisfies the equation that also lives in the restriction. So there's two things we need to check for. Theta needs to satisfy the equation and it needs to live in the restriction. If it satisfies both, then that's the answer for your inverse trig function. Okay, so the reason why Justin chose the negative pi over 2 is because sine is the y-coordinate on the unit circle. The y-coordinate on the unit circle is negative 1 down here at 3 pi over 2, which is coterminal with negative pi over 2. Okay, one more inverse trig function to cover. Let me check if there are any questions in my chat. Okay, so there are a few pages here for this section. The problem's level of difficulty progresses. So now tangent is a little more challenging. We treat it the same as in tangent is not a one-to-one function. So in order to define the inverse as a function, we need to define the restriction. So just like we saw with everything else, tangent of theta is equal to a ratio. That ratio is y over x or opposite over adjacent. So for the inverse, we switch the inputs and outputs. The ratio comes inside and the angle goes outside. However, there are going to be infinitely many angles that satisfy that equation. So to define inverse tangent as a function, we have to find the theta that's between negative pi over 2 and pi over 2. And this time it's exclusive, which means we're not including the endpoints. The reason why we can't include the endpoints is because at negative pi over 2 and pi over 2, we have vertical asymptotes. So the answer would be undefined. Okay. These problems are now a little more challenging. Find the exact value means we need to get radians. let's do these three together. So we set our inverse trig function, inverse trig function equal to theta. Okay, then we do the switch. So, and we say tangent of theta is equal to -1. When we go from inverse tan to tan, we switch the inputs and outputs, but we have to find the theta that satisfies the equation and lives in the restriction. So it needs to satisfy both the equation and the restriction. Okay. So let's think about this and we'll hear from Miguel. Miguel, at what theta value is your tangent -1 and theta between -pi/2 and pi/2? Not quite, because at 3 pi/2 right here, your coordinates are 0, -1. So tangent would be undefined there. So tangent is going to be plus or minus 1. That's in the 45-degree group. Because in the 45-degree group, your x and y, the legs are the same length. So if the legs are the same length, the ratio of y over x is going to be 1 plus or minus 1. Okay, so in quadrant 1, you have positive, positive. In quadrant 4, you have positive, negative. So Miguel, what is this radian measure here? Those are the coordinates, yes. So at this angle measure, our coordinates are, yes, that's 7 pi/4, but what is the answer in the restriction? Correct. Very good. So you're able to talk through the solution. Excellent. Okay. So we know that at this blue line, the coordinates are √2/2, -√2/2. Remember, tangent is defined as y over x. So tangent at that angle is -1. That satisfies the equation. Next, we need to find the angle that lives in the restriction. So at that blue line, the angle that's between -pi/2 and pi/2, that would be -pi/4. Your answer has to satisfy equation and restriction. Okay. So with these reciprocal inverse functions, when you go from inverse cotan to inverse tan, you're going to reciprocate the inside. So for reciprocal functions, you reciprocate, but for reciprocal inverse functions, you reciprocate the input. To go from inverse cotan to inverse tan, we reciprocate the input. So now we do the switch. We want to find an angle such that tangent of theta is equal to √3, and also theta is in the restriction between -pi/2 and pi/2. Needs to satisfy both equation and restriction. Okay, so let's take a look at our half circle here. So students, do a little bit of side work and in the public chat, tell me, what radian measure do you think satisfies the equation and lives in the restriction? So you may want to do a little side work to see which coordinate is my y over x square root 3? And what is that angle measure? So please share in the public chat when you're ready. We're trying part B, but we're going to share publicly this time, so we can check our answers with each other. You need to find theta that satisfies tangent of theta is equal to root 3. And that theta must be between negative pi over 2 and pi over 2 exclusive. Theta must satisfy equation and restriction. Okay, 3 students are saying pi over 3. Oh, Esmeralda, do you still need to see the first page? Please unmute yourself. Esmeralda, can you hear us?
No, I got it from Genesis. Thank you.
Okay, great. Okay, so let's try pi over 3. So we're thinking, is it long leg, short leg, or short leg, long leg? If we want the root 3 on top, the root 3 should be the y coordinate, and the 1/2 should be the x coordinate. So when long leg is the y coordinate, short leg is the x coordinate, then y over x is root 3. So that's going to occur at short long, which is pi over 3. Excellent. Okay, so right here at short long, the tangent is root 3 because the y over x is going to be root 3. And this is at pi over 3. Pi over 3 does live in the restriction, so we're good. Okay. So theta is pi over 3, which does live in the restriction. Okay, last one. Inverse secant of negative 2 is equivalent to inverse cosine of negative 1/2. So to go from inverse reciprocal to inverse function, we reciprocate the input. Okay. And then from there, we need to find theta that satisfies the equation. Cosine theta is equal to negative 1/2. And that theta must be between 0 and pi because the restriction for inverse cosine is between 0 and pi. Oops. Between 0 and pi. Okay, so our goal is we want to find theta such that theta is between 0 and pi. Okay. Between 0 and pi and satisfies the equation. So let's see. Our x coordinate is negative 1/2 right here. This is 2 pi over 3. 2 pi over 3 does live in the restriction, so we're good. We find the radian measure that satisfies the equation and also lives in the restriction. Okay. Let's pause for a moment to see, are there any questions on how we found the inverse trig functions by applying our unit circle knowledge? So applying our unit circle knowledge, we have to find the angle measure that satisfies the equation after we do the switch, but that also lives in the restriction for the inverse trig function. So it needs to satisfy both equation and restriction. I know I've repeated that, but that's a central concept here. Okay. If we're good to move forward, just put in a G. There's one more thing I want us to do before we take our break today. At the end of 4.1, I'm going to summarize the restrictions, and I'd encourage you to jot that down on your reference guide. It'd be a good idea for you to have a reference guide for every chapter as you're working through the homework problems. So Justin, Genesis, Stephanie, Hector are good to move forward. Other students, do we have questions? Jimmy and Juan are good too. Miguel, thank you. And Jacob, okay. Okay, so in chapter 4, we're going to learn sometimes we can use our unit circle knowledge to get the exact answer. Other times it's not on the unit circle and we have to use our calculator. Now, for exam 2, 3, and the final, we're surely going to be using our calculator. Well, really for all the exams, we're using our calculator, but particularly for what's to come, we're going to have to be ready to change our calculator from degree mode to radian mode, back and forth. If your calculator is not in the right mode, it's going to generate an incorrect answer. Okay, so when you go into these problems, before you use your calculator to put in trig functions or inverse trig functions, check the mode. So this time, if you don't see any degree symbols, we are in radian mode. So right now, in your scientific calculator, you should see a little R. In your graphing calculator, if you go under mode, you should see RAD highlighted. If you want to check that your calculator is in radian mode, put in, let's say, sine of pi over 2. The answer should be 1. Okay, so you can test that. Okay, students, so go ahead and try to find the inverse tan and then inverse cosine. So remember, arc secant of 6.2, that's arc cosine of 1 over 6.2. Okay, so I want you to try A and B in your calculator, and you're going to share publicly. So share publicly. Oops. See if you're able to use your calculator to get inverse tan of 5 and inverse cosine of 1 over 6.2. In my graphing calculator, when I go second tangent, that gives me inverse tan. When I go second cosine, that gives me inverse cosine. Remember to go from arc secant to arc cosine, you reciprocate the input. Reciprocate the input. Okay, so share publicly your answer for A and B. Your calculator needs to be in radian mode. And we will be going back and forth from radians to degrees. Let's round our answer to 3 decimal places. Okay, looks like we're in agreement. I know I didn't say the rounding up front, so that's fine. The MyMathLab software, though, will always specify the rounding instructions. Okay. I see we're in agreement. So inverse tan of 5, that's 1.373. So you find this in your calculator. Inverse cosine of 1 over 6.2, that's 1.409. So both of these answers can be found in the calculator. Any questions on how we are able to get those approximations from our calculator? Okay, students. So when we come back from the break, we're gonna finish up 4.1. We'll work in our breakout rooms. So let's come back at 9:40. So be back from break at 9:40. I'm gonna pause the recording while we go on break. And students, if you do have individual questions or you missed notes, you want to get screenshots, we can take care of that at the end of class. Let me pause the recording here.
Recording stopped.
So students that came in late, if you have questions for me or you'd like to take screenshots of the notes, check in with me after class. Right now we're on break and we'll be back at 9:40. Okay, let's come together. Please put in a B for back. Now that we have learned about the 3 different inverse functions, inverse sine, inverse cosine, inverse tangent, we're going to look at different application problems that will put a double star, meaning you should go back and review problems that are similar in preparation for quiz and exams. Okay, so I see Genesis, Khalid, Stephanie, Juan. Students, please put a B for back so I can mark you here for the second half of the class. Genesis, Khalid, Stephanie, Juan, Esmeralda, Justin. Think we're still missing a few students. Oops. Okay, so Hector, Jimmy, Jacob, can you hear us? Miguel? Okay, so I'll check in with those students as we resume. So let's go ahead and continue the recording. Okay. 1, 2, 3. Yeah, so Hector, Jimmy, and Jacob, can you hear us? Oh, there's Jacob. Okay, Jacob, is your connection working? Thank you, Miguel. I got you down. Okay, Jacob, can you hear us? Jacob, I think you're on mute, so please put a message. I'm assuming that our audio is good.
Sorry.
Okay, great.
Yeah.
Thank you.
I
You're- Okay. Yeah, Jacob, your audio is
got
breaking up
kicked
a
out.
little. Yes, but are you able to hear me? You can put it in the chat. Okay. So let's resume the recording. Thank you, Jacob.
Recording in progress.
We're going to continue in section 4.1. So on the last 2 pages, these are problems important for us to review and practice. So put those double stars. We're going to do one together, and then you're going to try the remaining parts in your breakout rooms. Okay. So when we are composing functions together, we want to start with inside function and then outside function. Let's put in a couple of notes here when it says find the exact value. Your answer should be in radians. Also note here 1 over square root of 2. That's equivalent to square root of 2 over 2. And then when we have an inverse trig function, we set that equal to theta. Okay, so we do inside function and then outside function. Okay, in that order. So we'll start with arc sine of root 2 over 2. The inverse trig function, we set it equal to theta. To find the exact value of the inverse function, sorry, students, I just need to check. Yes, okay. To find the exact value of the inverse trig function, we switch the inputs and outputs, and we want to find theta that satisfies the equation and satisfies the restriction. So we need to find theta such that sine of theta is equal to root 2 over 2 and theta is between negative pi over 2 and pi over 2. Remember, it needs to satisfy equation and restriction. I like to draw out half circle to help me visualize. So we know that root 2 over 2 is a twin group. The x and y coordinate are root 2 over 2 here at pi over 4. So pi over 4 is in the restriction and satisfies the equation. Okay. So inverse sine of root 2 over 2, that's going to be pi over 4. Now we do the outside function. So this was inside. Now we do outside. Outside, we want secant of pi over 4. So the inside function, we evaluated it and got pi over 4. The outside function is now secant of pi over 4. That's the reciprocal of root 2 over 2 because cosine of pi over 4 is root 2 over 2. So secant of pi over 4 is going to be 2 over root 2. That's the reciprocal of cosine. And we rationalize the denominator. We get 2 root 2 divided by 2. 2 divided by 2 is 1. So our final answer is square root 2. To find the exact value of the composition, we need to evaluate inside function and then evaluate outside function. Okay, so for 1, you're going to try part B, C, and D in groups. But before we go to the breakout rooms, we're going to do a few more together. Are there any questions on how we evaluate these compositions? Do the inside first, then the outside. And whenever you're working with inverse trig functions, make sure that your answer is in the restriction for that inverse trig function. If you get a coterminal angle not in the restriction, your final answer may be wrong. Okay, so earlier, let me turn that off. We were missing a few students. So Jimmy and Hector, can you hear us?
Yes, Professor.
Okay, great. Thank you, Hector. And Jimmy, are we good? Yes, okay. Oops. So in groups, we're gonna finish off this page. Let's move down. Calculator activity we'll discuss, but let's go to the last example in 4.1. This is also a double star. So for these double star examples, I do want us to have time to discuss and practice on our own, go through the full solution step by step. Okay. We'll always put a reminder to ourselves that when you see an inverse trig function, you want to set it equal to theta. Okay. So this one is these compositions are a little different because they don't give us the input. The input is x. So we're going to draw a right triangle. And this is a strategy that's going to be helpful that you'll use to in calculus second semester calculus. Okay, so you're going to set the inverse trig function equal to theta. Okay. So here let's put in arc sine of x is equal theta. That means sine of theta is equal to x. So inputs and outputs switch. Okay, so we're gonna now draw a right triangle. Because when we draw a right triangle, we know that theta will be in the restriction. When we draw the right triangle, we're in quad 1, and quad 1 is in the restriction for all inverse trig functions. Okay, so we can write x as x over 1. So once we set the inverse trig function equal to theta, we get trig function of theta is equal to a ratio. And we know that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent would be opposite over adjacent. Okay, so put in that SOHCAHTOA reminder. So since sine of theta is opposite over hypotenuse, that means that in our right triangle, the ratio of opposite to hypotenuse is x to 1. We've learned in chapter 3, when we are introduced to the triangle method, that once we have the length of two sides of the right triangle, we can easily solve for that third side. So for that third side, we'll call it A. We do leg squared plus leg squared is equal to hypotenuse squared. Okay, so let's solve for A. So A squared is equal to 1 minus x squared. In the right triangle, the legs are positive, so A is positive square root quantity 1 minus x squared. So A is positive square root quantity 1 minus x squared. Now that you have all three lengths of the right triangle, we can do the outside function. So our original question is, what is cosine of theta? In our right triangle, cosine of theta is the ratio that's adjacent to hypotenuse. So that's square root 1 minus x squared over 1. That's just square root 1 minus x squared. Okay. So when you're not given the x value, then you use the right triangle method, where you set the inverse trig function equal to theta. You identify the lengths of the right triangle, and then from there you can find any trig function evaluated at theta once you have set up your right triangle. Okay. So this one, in your breakout rooms, you're going to try B and C in groups. Are there any questions on how we are able to evaluate the composition using the right triangle method? When you put the theta in the right triangle, theta is now in the restriction, because the restrictions for inverse sine, inverse cosine, inverse tangent, all three of those restrictions include quadrant 1. Okay. I think we lost Jacob again with the connection. Okay, students, so I'm going to pause the recording while we're in the breakout rooms.
Recording stopped.
And let me repeat to show us. So in the breakout rooms, you're going to work on the 2 double star problems. So part B, C, and D for a problem on page 4. And then part B and C for a problem on page 5. So let me repeat that. In groups, you're working on part B, C, and D for the example on page 4. And then you'll work on part B and C for the example on page 5. So you have 5 parts to discuss in groups. You may want to work independently initially, but do collaborate and check your answers with those in your group. Okay. So let me open the breakout rooms. If you want to stay behind in the main session to grab screenshots, feel free to do that. Okay, go ahead and join your groups. Stay behind if you want screenshots of any notes that you've missed.
Let me know when you're done and then we'll swap answers. Mm-hmm. Mm-hmm. Yeah, and then that one would be 1/2. Because negative pi over 3 is technically 5 pi over 3. Yep, so then you would plug that into cosine, inverse cosine, and then you put that where the cosine negative 3 was. And then you flip it back to you do the inverse. So then cosine of theta equals 1/2, and then theta is pi over 3. Because cosine theta equals 1/2 would be the theta would equal pi over 3 since it's positive. Yeah, I did all mine. I was doing mine when she was talking. So let me know when you're
So what did you get for number letter B?
for letter B, I got the inside is 1/2. So cosine negative 3 or negative pi over 3 is 1/2. And then you put the 1/2 into the cosine, inverse of cosine, and then equal to theta, and then you do the inverse of that, which is cosine theta equals 1/2, and then theta equals pi over 3 since it's positive.
Thank you.
You're welcome. pi over 2. Because the restriction is negative, because negative 1 would be pi over 2, because the restriction is from pi over 2 to negative pi over 2. And you can include those. Oh, well, actually, technically you could have, no, yeah, it has to be pi over 2. And then you would plug pi over 2 into the equation, and then it's 1. And then for D, remember that because it's tan negative pi over 4, which is technically 7 pi over 4.
So students, Justin, Hector, Jimmy, and Miguel, Jacob is joining the discussion. So please fill him in on what you were discussing before. Thank you.
What question are you guys on?
We finished. Well, I'm done with all of them if you need help, but we've done as a group so far as B, C, and D on the first set.
And so you're on the next set?
I'm finished though if you need help.
No, that's all right. I can just go on the second set. I'll do the other set later.
Okay.
Are we on A or B?
I don't know where everyone else is at. Where are you guys at? Okay. For which one? For D, negative. For which set of problems? The first set? On D, I got negative pi over 2. Because tan negative pi over 4 is negative 1. And then you plug that into the inverse of sine. And then you do the inverse of that, which is sine theta equals negative 1. And then sine theta equals negative 1 at negative pi over 2, because the restriction is negative pi over 2 to pi over 2. So you all, like she said, you always have to express it in the restrictions. So if you express it, if you give it like a coterminal angle or a terminal angle, it's going to mark it wrong. It's going to mark it wrong in the system because of the restrictions. So you have to do it between those two. It's actually tangent 7 pi over 4 because it's a negative. So you go pi over 4 downwards from the terminal side, which is 0. So then it would be negative square root 2 over 2 divided by square root 2 over 2, which is negative 1. And then if you guys are on the second set, remember that you have to, well, technically it's all of them are the missing sides of the triangle is square root 1 minus x squared. So you can use the same triangle that we did for letter A when she did it with us. You just gotta put it appropriately on which side it's supposed to be on though, based off of the equation.
Justin, for B on the second page, what was your final answer?
My final answer is square root 1 minus x squared over x.
Okay. Okay, that's what I got. Just making sure.
Sweet.
Okay, students, were you able to discuss both examples? So 5 parts altogether?
I think a few people have a few more, like one more left.
Okay, we'll be back in the main session soon. And pay attention to details here because when you're putting in the software, you need to type in the exact answers, check in with each other.
And Justin, for part C, did you get 1 over x on the second page?
Yeah, I did.
Okay.
Okay, great. I see everyone is back now. Okay, so I'm gonna call on students to share what they found in the discussion. I'm gonna first take a picture of the participant list and we'll go in order. So Esmeralda, let's check your mic. Can you hear us? Esmeralda, please unmute. Okay, so Esmeralda, we've been having trouble hearing you. So we'll come back to Esmeralda. Let's resume the recording.
Recording in progress.
Okay, so continuing in section 4.1, we'll be sharing answers for these two problems. Let's go to Genesis. So Genesis, starting with the first problem, part B, we want to find the inside function first and then the outside function. Okay. Okay, so what is the exact value for the inside function?
For the inside, that's a -1/2.
Yes, so negative pi over 3 is coterminal with 5 pi over 3. And then we know at 5 pi over 3, our x coordinate is 1/2, y coordinate's negative or 3 over 2. So cosine is 1/2. Good, so now we have for the outside function, we have inverse cosine of 1/2. That's equal to theta. To find the exact value of an inverse trig function, we have to get the theta value that satisfies the equation and also that's in the restriction. So for inverse cosine, let me go back to the participant list. Okay, so Hector, for inverse cosine, what is our restriction for theta?
Can you hear me?
Yes.
Oh, okay. Pi over 2.
So when we're working with inverse sine, our answer must be between negative pi over 2 and positive pi over 2. When working with inverse cosine, our answer must be between 0 and pi. Between 0 and pi. Okay, so Hector, for this one, we need to find theta that satisfies the equation cosine theta equals 1/2. And that also is between 0 and pi. What did your group get for this part B?
Part B, pi over 3.
That's right. Because at pi over 3, your cosine value is 1/2. And pi over 3 is between 0 and pi. So it satisfies both equation and restriction. That's correct. Okay. So notice here that because negative pi over 3 is not in the range for inverse cosine, when you did the inverse function composed with a function, you didn't end up with the input. You can't just cross that out because they have different domain and range. So you have to evaluate inside function first and then outside function. Okay. So for example, negative pi over 3 satisfies the equation cosine of theta equals 1/2, but it's not in the restriction. You have to find the radian measure that satisfies both. Okay, at any time if you have questions, stop me so we can discuss. Okay, we will move forward. Let's go to Jacob. Okay, so Jacob, for part C, we need to work inside and then outside. We want to find inverse sine of 1. Inverse trig function is theta. So Jacob, we want to find the theta that satisfies the equation and that's in the restriction. So Jacob, what is the restriction for inverse sine?
It's negative pi over 2 and then pi over 2.
Good. So the reason why I ask students is when you say it out loud, it's being reinforced. And we want to learn these restrictions. Okay. So Jacob, in the restriction, where is sine of theta equal to 1?
Pi over 2.
That's right. So pi over 2 satisfies the equation and also is in the restriction. Very good. So that's step 1. That's your inside function. Your inside function comes out to be pi over 2. Now step 2, we need to find sine of pi over 2. Okay, let's see the list here. Jimmy is up next. Jimmy, what is sine of pi over 2?
1.
That's right. So that's your final answer. So when you're composing inverse with the function or function with the inverse, sometimes you get the original input, sometimes you don't. You have to check the restrictions. So always work inside function first, then outside function. Okay, let's move forward. Inside and then outside. Next on the list, we have Justin is going to help us with tangent of negative pi over 4.
It's going to be -1 because it's technically 7 pi over 4.
Very good. So it's in the 45-degree group in quadrant 4, so tangent is negative. Okay. Great. And then we have inverse sine of -1. The inverse trig functions we set equal to theta to help us find. We do the switch. Oops. Okay, so we do the switch and we find the theta in the restriction. Jacob told us that inverse sine is restricted to be between negative pi over 2 and pi over 2. So we have to find the theta that's between negative pi over 2 and pi over 2. Okay, so Stephanie, what is that theta in the restriction that satisfies the equation?
Negative pi over 2.
That's right. So 3 pi over 2 would be coterminal, but in the restriction, that would be negative pi over 2. And so if you answered 3 pi over 2, it would be marked wrong because inverse sine cannot be outside of the range negative pi over 2 to pi over 2. The inverse trig functions do have restrictions. Okay. So this would be a page that you want to review when you're doing composition of functions. Do the inside, work that out, then do the outside. And then remember, anytime you're working with inverse trig functions, you have to find specific answers in the restrictions for the inverse trig function. Okay, so let's go to the last page together. Remember, if you have questions, put it in the chat. If you missed anything, I'm happy to share my screen after class. Okay, Esmeralda, thanks for letting us know. Yes, for some reason, the audio isn't connecting. So maybe you can respond in the chat. So let's go to Esmeralda for the next part, and then we'll see if our answer matches. Okay. So when you are doing the compositions in your calculator, you also want to do inside first and then outside. So you do the inside one, then the outside. We'll round to 3 places. Okay, so Esmeralda, start us off by telling us what are you getting for part A? And reminder that since your inputs do not have degree symbols, your calculator must be in radian mode. So you may think, oh, my calculator's already in radian mode. That may be true, but when you're working on a quiz or exam, you'll be going back and forth. So you want to check for each problem. Okay, so students, type in the composition for part A Esmeralda is going to share her answer first, and then if you get the same, just type in same. Round to 3 decimal places. Reminder that if the last place is a 0, you still need to put it there as a placeholder. Okay. Oops. What happened there? So put that into your calculator. Esmeralda will be sharing, and students will be checking to see if you're in agreement. Okay, so yeah, so Esmeralda, after you get inverse cosine of negative 0.7, that's the inside function. So that was 2.3, oops, 2.346 dot dot dot. You don't want to round that. Remember, I think in my math lab it says do not round until final answer. So leave out all those decimal places. And then now, Esmeralda, find tangent of the input. Tangent of answer 1 will give you the final answer. So Esmeralda, share your final answer rounded to 3 places. This is a reminder that we do not round until the final answer. Okay, so students, check in with Esmeralda. So Esmeralda, I think what happened is if you're rounding the input answer, your output answer is going to be slightly off. So the input answer, inverse cosine of negative 0.7, that's 2.346193823. Do not round that number. Then you're going to take tangent of the input, which should be negative 1.02020 dot dot dot. So round to 3 places, negative 1.020. Okay. Stephanie, based on your answer, I think you may have been in degree mode. Yes. Okay. That's good. And yeah, so if that third place you're getting 1 instead of 0, that's telling me that you're rounding intermediate steps. It's going to mark that wrong. So you want to make sure the intermediate step, you leave out all the places. You only want to round your final answer. Inverse cosine of negative 0.7, that's 2.346193823. If you cut that off early, your final answer will be wrong. So if you put in negative 1.021, it probably would mark that wrong. Okay. Part B, let's try this one. So cotan of pi over 5. Remember, cotan is 1 over tangent. We're in radian mode. So this is going to be 1.376389192. Do not round that. When you do arctangent of that answer, you should get an error message. And the reason why you get an error message is because, so off to the side here, if you take arc sine of 1.376 dot dot dot, remember the inverse trig function is theta. So when we do the switch, because when we go from arc sine to sine, inputs and output switch, we see that there's going to be no solution for theta. Because think about the graph for sine. The range for sine is between negative 1 and 1. So sine of theta is between negative 1 and 1. Remember, the graph for sine of theta oscillates between -1 and 1. So sine of theta can never exceed 1 or go below -1. Therefore, there's going to be no theta value such that sine of theta is a value above 1. So the input for arc sine will always be between -1 and 1 for us to generate a solution. Here, there's no solution, meaning that this expression is undefined. So don't panic if you're getting an error message in your calculator. It may very well mean that the expression is undefined. Yes. A very good question. Yes, so most calculators don't have the reciprocal functions, but remember that cotangent, most calculators only have sine, cosine, and tangent, but for the reciprocals, we know that we use the identities. So cosecant is 1 over sine, secant is 1 over cosine, and then cotangent is 1 over tangent. So I just did 1 divided by tangent of pi over 5. Great. So 1 divided by tangent of pi over 5, that's your inside function. Do not round. Then for your outside function, you get undefined because we know that the sine of theta must be between -1 and 1. So there's no theta that will satisfy this equation. Okay. Anytime you're using your calculator to get a decimal approximation, check carefully that you type it in correctly and make sure that you're not rounding prematurely. Rounding prematurely can lead to careless errors. Okay, 2 more to go to wrap up section 4.1. We're going to hear from Khalid and Miguel. Okay, so Khalid, for part B, what are we going to set equal to theta?
Sorry, say again.
Yes, so we're moving to the last example, part B. What should we set equal to theta?
0.
So we set the inverse trig function equal to theta. The inverse trig function is inverse cosine of x. Khalid, do we see what we're doing here? We set the inverse trig function equal to theta.
I see, yeah.
Okay. Yeah, so that symbol that looks like a 0 with a line in the middle, like a little egg, Easter egg, that is the angle measure theta. Yeah, so we set inverse trig function equal to theta. And then now to go from inverse cosine to cosine, we switch the inputs and outputs. Let's go back to Khalid. So Khalid, cosine of theta is equal to x over 1. How should we set up our right triangle? Here's our theta. So remind us from SOHCAHTOA, cosine is the ratio of what two sides? Can someone in Khalid's group help chime in?
Adjacent hypotenuse.
Thank you. Yes. Cosine is the ratio of adjacent to hypotenuse. Thank you. Good teamwork. So when we set up our right triangle, the ratio of adjacent to hypotenuse is x to 1. We already did the calculation that if one leg is x and the hypotenuse is 1, our missing leg is square root 1 minus x squared. I'll just put C work above. So you set up your triangle. When you have 2 lengths of the right triangle, we can use Pythagorean theorem to find that third length. Okay, back to the problem. Tangent of theta. So remember, tangent is opposite over adjacent. Opposite over adjacent is square root 1 minus x squared over x. So part B, we should have square root of quantity 1 minus x squared, and then all divided by x. Last one, part C. Okay, so Miguel, what should we set equal to theta? Let's go to Miguel. Yes. That's right. We set the inverse sine equal to theta because inverse trig functions are equal to the angles. Trig functions are equal to the ratios. Inverse trig functions are equal to the angles. Okay, so if inverse sine of x is theta, that means sine of theta is equal to x over 1. So we do the switcheroo, and then now we have the info needed to set up our triangle, because we know we saw above here that sine of theta is opposite over hypotenuse. Okay, so let's set up our right triangle here. In relation to theta, the ratio of opposites to hypotenuse is x to 1. We already found the missing leg here with the work above. So again, I put C work above. So to find the missing leg, simply we apply the Pythagorean theorem. Leg squared plus leg squared is equal to hypotenuse squared. Okay, so now we have all three lengths of the right triangle. Justin, how do we find cosecant of theta?
Cosecant of theta is hypotenuse over opposite. So it'd be x over or 1 over x.
That's right. So sine is opposite over hypotenuse, which means its reciprocal cosecant is hypotenuse over opposite. Cosecant of theta is 1 over x. Correct. Okay, so the problems that you see in the lecture notes are going to be similar to what you see in the homework, quizzes, and exams. Homework sometimes extends beyond, help us with conceptual understanding. But the problems that are double starred, we should review, find problems that are similar for practice and reinforcement. Okay. Let's put down here that in chapter 1, I said we don't have to memorize this, but now that we're in chapter 4, we do need to learn the restrictions. You can always put this in your reference guide if needed. But with practice, we should be familiar. And this is something we want to store to memory for this class and moving forward, because we're going to be using this in the remaining sections. So inverse sine, to find inverse sine, you find the angle that satisfies the equation after you do the switch, but also it must be in the restriction between negative pi over 2 and pi over 2. For inverse cosine, again, you find the angle that satisfies the equation after the switch, but also that angle has to be in the restriction between 0 and pi. For inverse tan, find the angle that satisfies the equation after the switch and that lives in the restriction between negative pi over 2 to pi over 2 exclusive. If you're asked to find inverse trig functions of the reciprocal ones, such as inverse cosecant, inverse secant, inverse cotangent, you are going to reciprocate the input, and that converts it from inverse cosecant to inverse sine, or inverse secant to inverse cosine, or inverse cotangent to inverse tangent. So it's always best to write to convert in terms of sine, cosine, tangent, or inverse sine, inverse cosine, inverse tangent. Because we have more tools to find those values. Okay, so wrapping up 4.1, we learned about the inverse trig functions. Each of them have restrictions. To find the inverse trig function, you find the angle that satisfies the equation after we switch inputs and outputs. And then also that is in the restriction. And when we say restriction, this is the range for the inverse trig functions. Okay, so I can repeat these concepts over and over again, but students really do need the practice from the homework and textbook to be able to reinforce and feel confident about these concepts. Okay. We have a couple more items before we finish today, but this does conclude the section 4.1 recording. Are there any questions before I close out this recording?
Yeah, I just had a question regarding what you mentioned for cos or inverse of cosecant, secant, and cotangent.
Yes.
You said that we would change it to 1 over the inverse of tan or 1 over the inverse of cosine. Is that how we do it?
We reciprocate the inputs. So for example, if we had inverse cosecant of 2, that's equivalent to inverse sine of 1/2. So for the function, we reciprocate the outputs. For the inverse function here, we reciprocate the inputs. Or let's say inverse secant of root 2. That's going to be inverse cosine of 1 over root 2.
Okay, thank you.
Or we could even do inverse cotan, let's say inverse cotan of 1. When we reciprocate 1, it stays 1. So that's inverse tan of 1. Good question. Anything else related to inverse trig functions that I can help clarify? Jimmy, I'm not quite understanding your question. Can you expand?
We were talking about the range and the restrictions. Is said sine is negative pi. It's I think it's less than or equal to theta, and then theta is less than or equal to pi. Tangents just have the equal, is it not?
Oh, yeah, let me clarify. So for inverse sine, we said theta is between negative pi over 2 and pi over 2. For inverse cosine, theta is between 0 and pi. So for inverse sine and inverse cosine, these ranges are inclusive. For inverse tangent, it's exclusive. So inverse tangent is between negative pi over 2 and pi over 2. The reason why it's exclusive is at those endpoints. So tangent of negative pi over 2 or tangent of pi over 2 would be undefined. So that's why inverse tangent doesn't include the endpoints.
Thank you.
Okay, great. So pay attention to the restrictions. Inverse sine and inverse cosine have inclusive ranges. Inverse tangent has exclusive range. Okay, all great questions for our discussion. You see if I missed anything. So this concludes the section 4.1 recording. Let's stop it here.